Robots make our lives easier, but creating a robot to make our lives easier is not an easy task. In order to make robots follow human instructions, programming languages are used. Languages are used to program robots. History of robotic languages, nowadays robotic languages, drawbacks, future robotics languages, comparison of robot programming languages, the development of robot programming concepts, automated robot programming. Languages are used to program robotic languages are used to code software which tell a robot that what tasks to perform and control its actions. Programming robots can be a complex and challenging process because they should be programmed in a way that when the value of a variable changes, the value of other variables affected should also change. Thus, data flow languages are used to program most of the robots. Data flow language is a programming language that incorporates data flow principles. In addition to numeric processing, data flow languages also incorporate functional concepts. Unlike other programming languages which use imperative programming, data flow programming is modeled as a sequence of functions. Most of the times, robots are used for industrial purposes. Industrial robot programming languages are used to program this type of robots. Other than that, visual programming languages, scripting languages, and parallel programming languages are used to program robots. History of robotic languages. The history of robots has its roots as far back as ancient myths and legends. Modern concepts began to develop when the Industrial Revolution allowed the use of more complex machines, and the subsequent introduction of electricity made it possible to power machines with small compact motors. Digitally controlled industrial robots and robots making use of artificial intelligence have been built since 1960s. At the very beginning, in 1961, assembly language was used to program robots. The reason for using this language is that assembly language is closer to hardware. After some time, in 1967, when the Leo programming language was created, robot industry started programming robots in Logo. In 1973, Robot Freddy was created using Prolog language. In 1999, Oibo robot was created using R code language. In the year 2000, Asimo was developed using Lego Next language. There are 4 types of robot programming languages. They are industrial robot programming languages, visual programming languages, scripting languages, and parallel languages. Industrial robot programming languages include VAL, Epson, RC+, RoboFort, Lego, LabVIEW are some of the visual programming languages. Scripting languages are high-level programming languages that are used to control the software applications and is interpreted in real time or translated on the fly instead of being compiled in advance. a well-known scripting language used to program robots in Robotics. Another interesting approach is worthy of mention. All robotic applications need parallelism and event-based programming. Most programming languages rely on threads or complex abstraction classes to handle parallelism and complexity that comes with it, like concurrent access to shared resources. URBL, which is a parallel language, provides a higher level of abstraction by integrating parallelism and event in the core of the language semantics. There are 4 types of robot programming languages. They are industrial robot programming languages, visual programming languages, scripting languages, and parallel languages. Industrial robot programming languages include VAL, Epson, RC+, RoboFort, Lego, LabVIEW are some of the visual programming languages. Scripting languages are high-level programming languages that are used to control the software applications and is interpreted in real time or translated on the fly instead of being compiled in advance. A well-known scripting language used to program robots in Robotics. Another interesting approach is worthy of mention. All robotic applications need parallelism and event-based programming. Most programming languages rely on threads or complex abstraction classes to handle parallelism and complexity that comes with it, like concurrent access to shared resources. URBL, which is a parallel language, provides a higher level of abstraction by integrating parallelism and event in the core of the language semantics. Future robotics languages.
In the future, robots will also be used in homes, and ordinary people should be able to give tasks for robots to perform. This should be done descriptively using natural language, as in describing tasks to another person. In this work, an intermediate language for mobile robots has been presented. It makes it easier to design a new task for a robot. ILMR is intended for service and field robots, and it acts as an intermediate link from user, an intelligent planner, or a human-robot interface to a robot's actions and behaviors. The main principle in development work has been simplicity and ease of use. Neither any deep knowledge of robotics nor good programming skills are required when using ILMR. While easy to use, ILMR offers all the required features that are needed to today's specialized service and field robots. These features contain sequential and concurrent task execution and response to exceptions. ILMR also makes it easier to manage the development of complicated software projects of service robots by creating easy to use interfaces to all of several subsystems in robots. It is possible for users to use ILMR to give direct commands or tasks to a robot, but it is intended to be used with higher level abstract languages such as sign language or even natural spoken language through a high level planner. An action in ILMR can be given causally, example, in an abstract way or in detail. Causeness, ILMR is suitable to be used with higher level abstract language. Due to this causeness, ILMR is suitable to be used with higher level abstract languages, and the set of elementary commands supports directly the use of natural language. With ILMR, no complicated models of robots and the world are needed. Only a few measurable parameters for robots are needed, and a simple map of the environment is maintained. ILMR has been implemented in 2 different kinds of robots, and its use and performance has been studied. With ILMR has been implemented in 2 different kinds of robots, and its use and performance has been studied with simulators and actual robots in a wide variety of tests. The structure and operation of ILMR has proved to be useful, and several tasks have been carried out successfully using both test robots.
Automated robot programming.
Artificial intelligence, also known as AI, is the latest interest among the robotic programmers. They have developed several specialized programming languages for artificial intelligence. IPL, LISP, Prolog scripts, and Planner are some of those specialized languages for AI development. IPL was the first language developed for artificial intelligence. It includes features intended to support programs that could perform general problem solving, including lists, associations, schemas, dynamic memory allocation, data types, recursion, associative retrieval, functions as arguments, generators, and cooperative multitasking. LISP is a practical mathematical notation for computer programs based on lambda calculus. LISP is a practical mathematical notation for computer programs based on lambda calculus. Linked lists are one of LISP language's major data structures, and LISP source code is itself made up of lists. As a result, LISP programs can be manipulate source code as a data structure, giving rise to the macro system that allow programmers to create new syntax or even new domain-specific programming languages embedded in LISP. There are many dialects of LISP in use today. Among them are Common LISP, Scheme and Closure. A prologue is a declarative language where programs are expressed in terms of relations and execution occurs by running queries over these relations. Prologue is particularly useful for symbolic reasoning, database and language parsing applications. Prologue is widely used in AI today. SLIIT is a language for expressing automated planning problem instances. It expresses an initial state, the goal states, and a set of actions. For each action, preconditions and post-conditions are specified. Planner is a hybrid between procedural and logical languages. It gives a procedural interpretation to logical sentences where implications are interpreted with pattern direct inference. Other than these languages, AI applications are also often written in standard languages like C++ and languages designed for mathematics such as MATLAB and Lush.
The development of robot programming concepts.
The development of robot programming concepts is almost as old as the development of robot manipulators itself. As the ultimate goal of industrial robotics has been the development of sophisticated production machines with the hope to reduce costs in manufacturing areas like material handling, welding, spray painting and assembly. Tremendous efforts have been undertaken by the international robotics community to design user-friendly and at the same time powerful methods. The evolution reaches from early control concepts on the hardware level via point-to-point and simple motion level languages to motion-oriented structured robot programming languages. The robot programming languages can be classified according to the robot reference model, the type of control structure used under data, type of motion specification, the sensors, the interfaces to external machines, and the peripherals used. Point-to-point motion language, basic motion languages at assembler level, non-structured point-to-point motion language, basic motion languages at assembler level, non-structured high-level programming languages, structured high-level programming languages, NC-type languages, object-oriented languages, and task-oriented languages are some of the programming languages available for robotics.
Comparison of robot programming languages.